All right, so, wait, how do I do this? Okay. All right, so it's running. All right, people are clicking. Go, go, go. It's a race. I'll get all this other stuff started. All right, so keep clicking away. I got, all right, 63, 64. All right, oh, look at that, 67 people. Well, that's good. All right, 70 people. 70 people have voted. This is exciting for me to watch. Okay, and I think. All right, is that everybody? Anybody else still trying to get their clicker working? Okay, I'm gonna hit stop here. All right, okay, everybody click C. Change all of your answers to C. Oh yeah, look at that. All right, we got some people lagging. Change your answers to C. All right, I just want to see if it'll do the appropriate. Is something going on here? Am I missing a joke? All right, just leave it there. Okay. All right, I'm gonna hit stop here, and then I think I can like say the answer was C, and then all of these people, I don't know, get a point or something. I don't know how this works. Okay, and then I'm gonna click close so that I had 74 votes, and then I think I end the session. Oh, what? Miss you have two. Miss Rizu at UCLA, you got two clickers? You got two clickers. Look at you. Oh, okay. Wait, one of your clickers is not working? It wasn't working. Okay. Okay. All right. Which one's? All right. I guess we'll have to figure out which one's the. Okay. So I'm gonna try. Okay. Appears to be to resolve this problem. Find the student. Select the student. Confirm correct ID and remove the incorrect ID. Okay, that's fine. Let me sync the roster here. The remote or reef ID match a student. Oh, okay, this works. All right. Okay, so there are 4 clickers that are not registered to names. But let me see. Can you guys see this? Should I not put this up here? I don't know. I don't know what the privacy rules are. But okay, these are. So if you have one of these 4 clickers, it says it's unregistered. And okay, and then everybody else. Okay, I guess if you show up. Oh, I can't read this. Export. How do I? Okay. Session 2. Next. Okay, I'll export this and I'll post this somewhere. And it will be like, this is everybody who, so I guess, so this is our list of everybody who, this is impossible to read, but okay. Well, I'll post this up, but it's got, all right. I'll post the list of everybody who's got their clickers registered. Okay, and then oh, you guys have Monday off because it's Martin Luther King Jr. Day. So we'll see you on Wednesday. You'll still have lab on Tuesday, and I hope everything will be resolved. I'm not going to assign a new lab, so it's going to be the same lab, the baby boom, and then we'll resume our lectures on Wednesday. Is that cool? All right. Okay. So if you're watching on this thing on YouTube, sorry, there was a bunch of clicker stuff that we had to deal with, but I'm hoping everything will be all resolved, and everybody who's got their remotes in will be good. Okay. So we will continue on. I guess before I continue on, are there any questions on any of the topics we've covered so far? Nope. We're good? Okay. All right. So then let's we'll wrap up chapter 3, and the last topic is box plots. Okay. And so a box plot is a graph that looks something like this. This is what a box plot looks like, and it consists of basically a box, all right, and the box has 3 locations. This is going to be Q1, the median, and Q3. These are the boundaries of the box, and we also have kind of our min and max, but this is the min within the fence, and this is the max that's still within the fence. So these are the largest and smallest points that are within the fence. We have an imaginary fence somewhere like right here, and maybe over here. Okay. So these are our fence boundaries. This would be the lower fence and upper fence. And if we have any data points that are larger than the upper fence or smaller than the lower fence, they would appear as individual circles or dots. And they are, these things are outliers, or at least potential outliers. Okay, these ones also outliers. Okay, so it's almost like, so if there were no outliers, kind of your box plot would show your 5-number summary, essentially, right? Your 5-number summary is your min, Q1, median, Q3, and max. But what the box plot does is it also kind of sets up these boundaries and distinguishes what potential outliers are from other just, quote, regular points. All right, and so we should talk about the location of the upper and lower fence. All right, so the upper fence is located at Q3 plus 1.5 times the IQR, and the lower fence is located at Q1 minus 1.5 times the IQR. Okay, and so essentially the IQR is basically the width of the box, because our box is defined by Q1 and Q3. And what this effectively says is, it says take this width, this is our IQR, and then basically go that width, above, plus 1.5, right? So it says go 1.5 above here, okay? So this is, 1.5 times this IQR. Go that far above Q3, and then do the same thing below. This is 1.5 times the IQR, and that defines the lower fence. Okay. And this is kind of a slightly crude method of determining outliers. It's fairly good. There are many over time. Different statisticians and mathematicians have developed ways to decide, hey, this point is an outlier. This point is not an outlier. But and this is one method. And so, so this is how we decide the IQR and upper and lower fences. All right, is that cool? So let's try making one. Let me save these. Okay, so let's say, so this is some example. Let's say you planted a bunch of seeds, okay? And then, they started growing. I'm going to use, okay, you planted another seed and it started growing. Okay, and we're going to measure how tall each of these seeds grew, right? So they all right, and so let's say we got a bunch of seed growths. Let's say we have they grew. So this will be in millimeters. Okay, so we have 7 and 8 and 8 and 9. 9, 10, 11, 11, 12, 1, 2, 3, 4, 5, 6, 7, 8, 9. 10, 21, 29. How many is this? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so we've got 12 measurements here. All right, so let's figure out what our Q1, median, and Q3 are. Okay, and then tell me where the lower fence and upper fence are. And then tell me which points can be considered outliers. So I'll give you guys a moment to figure this out. So we have 12 data points. Okay, so where is our median? That's probably the first thing we should find. So that would be the spot that separates the lower 6 from the upper 6, right? So my median is at 10.5 millimeters. Q1 is then going to be, I split these 6 into 3, and I have 8.5, and over here I have 12.5. Okay? So my IQR is equal to 4. So my lower fence is Q1 minus 1.5 times the IQR. So I would have 8.5 minus 4 times 1.5, so 2.5 millimeters. And the upper fence would be 12.5 plus 1.5 times the IQR. So I have 12.5 plus 6. This takes me to 18.5. So 21 and 29 would be considered outliers. All right, so my box plot would thus look something like this. So if I just all right, this is, and so I draw a line at Q1, 8.5, which is going to be right there, a line at the median, and a line at 12.5, Q3. Okay, so these form my box. Lines go down to the smallest point within the fence, which is 7 over here, and then the largest point that I have within the fence is 13. Okay, so that's right over there. Okay, so you don't have to label these, but I'll just do this for illustrative purposes. And then I would draw outliers out at 21 and 29. Okay? If you wanted to, you could draw dotted lines where the fences are at 18.5 and at 2.5. But those are unnecessary. So, and usually if you create a graph on a computer or something like that, it will not put the fences there. Okay, and so this is, there's our box plot based on our 12 data points. Now, the great power or the usefulness of a box plot is that basically it's even more compact than a histogram, okay? So, you know, a histogram displays your distribution of data, and you can see exactly where the peaks are, and, you know, whether it's bimodal or skewed or things like that. With a box plot, it just boils your data down really just into basically 5 data points, or 5 spots. You've got the box, you've got some whiskers, maybe some outliers. Okay? And so looking at this box plot, can you tell if the data is skewed left or skewed right or anything like that? What would you say? It's skewed right, right? Okay, we've got the middle here. We have some values that are much larger than the quote middle, okay, and we have nothing that's much smaller. So from the box plot, we can still say that it is skewed right. Okay, I'm going to flip to the next slide, and you know, when you look at a box plot, you can also get a sense of the spread in your data. Okay, so if this is one box plot and you have another box plot that looks like this, so let's say and then you have another box plot that looks like this. Okay, you can look at so all of these have effectively the same range, right? So there's no outliers. They all have the same min and they all have the same max. Okay, so the range is the same for all 3 data sets. Okay, so each box plot represents a different data set. However, we can, just by looking at the box, the width of the box tells us the IQR. And so, you know, we can say, you know, this has the least spread. And this has the most spread. Okay, just by looking at the width of the box. What about the measures of center? Can we say anything about the measures of center? They are all about the same, okay? I mean, these two, the medians are right about the same. And this one we can see that the median is just ever so slightly lower than the medians of the other box plots, okay? But we can effectively say, you know, the centers are about the same. Okay. Median is about the same value. Okay, and if I guess I could label these A, B, and C. You know, maybe data set A has a slightly lower median. Than the others, okay? So, you know, a box plot, you know, you can just look at the width of the box, get a sense of the spread, okay? You know, this is just a silly illustration. In other cases, you know, you could just look at the position of the box itself, and that will tell you whether the center is higher or lower, okay? So, you know, just you can have a box plot like this, and then you can have another box plot. That looks like this, okay? And so, you know, assuming these are on the same scale here, whatever, you know, you got some kind of number line here, right? 0 to 100, okay? Whatever we're talking about. You know, we can look at data set A and data set B, and we can say, you know, data set B has a higher center than data set A. Okay, just comparing medians. Okay, so we got the median right there and the median right there. Okay, and in fact, the median of data set B is right around where Q3 is of data set A, okay? Median of B is about the same as the median, not median, as the Q3 of A, okay? So, you know, what does that mean? So the median, this is our 50th percentile. 50th percentile over here is equivalent to the 75th percentile over here, which I think is pretty significant, right? And it's hard to, okay. Here's a question. What percentage of the data is between here and here? What percentage of B's data is in this red region? Okay, I think you guys got this. You know, 25%, because this represents the 75th percentile. So 25%'s up there. So, you know, this effectively breaks it up. Each of these is, I should say, you know, from here to here is 25%, from here to here is 25%, and from here to here is 25%, okay? Would you say are either of these skewed left or skewed right or symmetric? What would you say? You know, I would say mostly symmetric, okay? Because in both of these cases, the median is pretty close to the center. I mean, ever so, you know, if we were to measure how far down here to here is and how far from here to here is, maybe it's a little bit longer this way. But overall, you know, they look pretty close to symmetric. All right, so both are pretty close to being symmetric. Okay. So that's box plots there, and I think that wraps up in terms of new content in chapter 3. I do want to maybe address some of the questions that that students had regarding the lab, and there is one type of graph that shows up in the lab that we did not discuss, and it doesn't make an appearance in the book, okay? And so, you know, that thing is the ribbon chart, okay? And so the ribbon chart looks something like this. You know, how do we read a ribbon chart? And, you know, maybe we do or don't want it, okay? And it probably looks something like this when you create it. And this was like, I don't know, they colored these things in. Hello. Okay, so we got this, something like this. Okay, and this was kind of like non-smokers up to here, and smokers over here, right? Something like this. Okay, and then this would be normal birth weight. And this would be the low. Something like that, right? Does this look familiar, or am I just talking?
Yeah.
Okay. All right, so what does this mean? Okay, so what this picture does is basically this whole chart, this whole rectangle is supposed to represent 100%, okay? So the entire rectangle is 100%, okay? And then basically, if we just looked at the width of the thing, you know, whatever, I'm making up numbers here, but you know, maybe non-smokers, there was 85% or something, and smokers represented 15% or something like that, okay? And so what this means is that, you know, if we looked at the entire population and split it between smokers and non-smokers, 85% are non-smokers and 15% were smokers, okay? Within these non-smokers, okay, we have, you know, the normal versus the low, okay? And so, you know, if I were to measure this height over here, this height then becomes the new 100%, okay? And then so, you know, I don't know what the numbers are. I'm going to just make it up. So, you know, this maybe this is 1/10 of the height over here, or, yeah, maybe less, 8%, okay? So what this thing is, then it says for the normal, for the non-smokers, 8% of the babies were low birth weight. And then for the smokers, maybe this is, I don't know, 18%, okay? And so what the ribbon chart allows you to see is it says, hey, you know, these two things, they are not the same height, okay? All right, this is 8%, over here it's 18%. These two things are not the same height, Therefore, perhaps smoking has something to do with low birth weight. Okay? So, because the the white region, I don't need to put white in quotes, because the white region are different heights, that means the what we call the conditional percentages are different. Okay, so the low birth weight babies appear at a different percentage for non-smokers as they do smokers. Okay. Okay, that's fine. What would our ribbon chart look? How would our ribbon chart look if the two variables we were talking about were independent or had nothing to do with each other? So, if smoking is not associated with an increase of low birth weight babies, how would our ribbon chart appear in that case? Yeah.
The low birth weights would have about the same percentage.
Okay, so so what we would see, and I'll do this on the next slide here. Okay, we'll still have this rectangle, and what effectively we'll see is just kind of this pattern, something like this. Okay. And the shading darn this thing. Okay, the shading would appear something like that. Okay, and in that it's not going to make things more equal. I mean, you're still going to have more non-smokers than smokers. Okay. And you do have smokers. But what you have is that this percentage is the same over here as it is over here. Okay, so the low birth weight percentage and the low birth weight percentage over here, they are as far as the percentage heights go, okay, they are the same height. Okay, but when you look at the data, and you look at your summary table, you could have, something like 800 and 200 and 20 and 180 and 80 and 720, okay? And so, when you look at the numbers themselves, you're still going to have a larger value over here than you do over here. But that's just because there's more non-smokers than there are smokers, okay? And so if you looked at relative percentages, so, we turn these into column percentage. Okay, so column percentages, 80 over 800 would be 10%, 90, okay, 100%, 1.00, and then 180 over 200 is 90, and then we would have this thing. Okay, so our column percentages would reflect that low birth weight babies appear, at a rate of 10% for non-smokers and at a rate of 10% for smokers. So this is, if smoking and low birth weight had no association. This is what we would see regarding percentages and such, okay? And so, you know, you can create all sorts of bar charts, and bar charts are fine, but, you know, if you graphed just counts, you get something that looks like this. Right? And this would be the smokers and the non-smokers or something, you know. You can create all sorts of things. You need to put these on the same scale to see if indeed there's a connection or not, okay? And so the ribbon chart's one way to do it. But, you know, I think the bar charts that appear in Fathom are pretty, are also high quality. And so, you know, either a ribbon chart or a bar chart could be used. But the disadvantage of ribbon charts is that most people probably haven't seen them before, okay? Prior to Fathom, you probably, you know, ribbon charts are not frequently displayed in newspapers or anything like that, okay? And so the first time someone encounters it, they might not know how to interpret it. So that's just something to keep in mind. Okay, that's all I've got for today. We'll end a few minutes early. And have a great weekend. We'll see you guys. Well, you'll have lab on Tuesday, and I'll see you guys on Wednesday.